In the last video, we learned how to make the molecular orbital energy diagram for 3 different molecules. The first one was hydrogen gas. In this video, we're going to talk about how to write the electron configurations of these molecules. Just like when we wrote electron configurations for atoms, we're going to use an Aufbau diagram to describe where these locations are. All we need to do is write the molecular orbital in parentheses and tell how many electrons are there. For nitrogen, we have a few more electrons we need to describe. First, we'll start with these guys that are from the molecular orbitals created by the 1s atomic orbitals. So I'll describe sigma 1s, and there's 2 electrons in that orbital. Sigma 1s star for the antibonding orbital, and there's 2 electrons there. Now I'll move to the second part. Sigma from the 2s, and there's 2 electrons there. Next, antibonding sigma orbital, 2s. And then we have to describe the p's. We have 4 electrons in the pi bonding area and 2 electrons in the sigma bonding. So basically, you would write the electron configuration of a molecule like nitrogen exactly the way you would write an electron configuration for an atomic orbital. In oxygen's molecular orbital energy diagram, you can see that the sigma 1s and the sigma 1s antibonding orbitals stay the same, so do the sigma 2s and 2s antibonding orbitals. However, the sigma 2p and the pi 2p orbitals change locations, so you're going to have to make sure that you switch that in the electron configuration. We'll start off by writing down the sigma 1s orbitals, 2 electrons in there, check. The sigma 1s antibonding orbital, 2 electrons in there, check. Sigma 2s orbital, 2 electrons in there, check. Sigma 2s antibonding orbital, 2 electrons in there, check. Sigma 2p, 2 electrons in there, check. Pi 2p, total of 4 electrons in that guy, check, check. And lastly, the antibonding pi orbital made by the 2p's, there's 2 electrons in there. And that's how you write the electron configurations for simple molecules.